Guys, it's Matt Storm here with a video about intermediate factorization. In factorization, one of the multiple methods to factorize is the polynomial formulae method. You may be given a very complicated expression to factorize that you may not know at first how to do it. In some cases, you can factorize it using the normal methods, such as double cross and single cross method. If it's too high variable, you might not even be able to use the pivoting, completing the square method either. So you will need to use the polynomial formula. If you can identify some similar format of a well-known polynomial formula, then that might be the key to factorizing the expression. For example, if you're given a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac, then you might be able to immediately recognize that this equals to a plus b plus c in parentheses squared. This polynomial formula method takes a lot of practice because you need to be very sensitive about your polynomial formulas. A plus b plus c squared expanded equals to a squared plus ab plus ac plus ba plus b squared plus bc plus ca plus cb plus c squared. That will equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac, which is your designated expression. A more well-known method is the cross method factorization. The cross method, or the cross multiplication method, is one of the best and easiest to understand factorization methods when you're dealing with quadratic trinomials. Consider the factors of the quadratic trinomial x squared plus 7x plus 10. Clearly, the factors of x squared are x and x. So, the linear factors start off as x. You have to fill in the parentheses later, obviously. But first, just leave the first parentheses to be x and the rest of it blank. The second parentheses is the same thing. Now, consider factors of 10 to obtain 7x as the middle term of the expression. This is where the cross multiplication method is helpful. Factors of 10 are 1 times 10 and 2 times 5. Place the linear factors one above the other as shown below. Draw a cross and you get x and x on the left side, 1 and 10 on the right side. However, after multiplying the crosses, you get x plus 10x. That will equal to 11x, which is not the value in the middle term that you will want. So then you try the other combo. X and x are still on the left side, but this time 10 is split into 2 times 5. The sum of the diagonal multiplication will be 7x. This is the middle term. So x squared plus 7x plus 10 equals to x plus 2 times x plus 5. Now you know how to use the cross method. Let's do an example. Factorize a squared plus 2b squared plus 3c squared plus 3ab plus 4ac plus 5bc. Problem: apply polynomial formula and factorize. The original expression equals to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca plus b squared plus 2c squared plus ab plus 2ac plus 3bc. You split the expression to this form because it's the well-known form of the polynomial formula we just discussed about. So then you can turn this expression into a plus b plus c squared. And then the next part can be factorized into b plus c times b plus 2c plus a times b plus 2c. You will be familiar with this kind of factorization after you learn about the grouping method. The grouping method is also related to the splitting method because you have to split the terms to factorize it. So let's get back to the problem. A plus b plus c in parentheses squared, and then you can factorize b plus 2c from the next two expressions. So it will be plus b plus 2c in parentheses times a plus b plus c in parentheses. And then factorize out a plus b plus c. So then you get a plus b plus c plus b plus 2c, which will equal to a plus 2b plus 3c times a plus b plus c. So the answer to the problem is shown on this big screen. Thank you for watching, and I hope now that you understand the intermediate factorization, you can apply the methods you used and learned to use in future competition.